Good morning, all of you. In this session, we'll solve some numerical based on second law of thermodynamics. This is the problem. I'm just taking this problem. A reversible engine, this is modified Carnot cycle, is shown in figure. It receives 100 kilojoule of heat at 500 Kelvin and another 40 kilojoule of heat at 400 Kelvin. Heat is rejected at 300 Kelvin, then the work output is equal to. Okay, so this is the modified Carnot cycle. This is a reversible closed modified Carnot cycle. This is shown on TS plot. On x-axis there is x-axis and this is y-axis. Okay, on x-axis entropy is plotted and y-axis this temperature is plotted. This is in this problem it is given that this 100 kilojoule of heat is added at 500 Kelvin. Okay. Now the another 40 kilojoule of heat is added at 400 Kelvin and heat is rejected at 300 Kelvin. This heat is rejected at 300 Kelvin. So in this cycle we have to find out the work output, right? Okay. So we know that this is a reversible engine and this is modified Carnot cycle. So this is reversible modified Carnot cycle. This is a reversible modified Carnot cycle. Okay. For this reversible modified Carnot cycle, the cyclic integral of, we know that as per Clausius inequality, we know that cyclic integral of dq by t is equal to 0. Okay. So for this process, we have to find this quantity. We know that this process 1 to 2, this process 1 to 2 is the isentropic compression process, right? So in this condition, in this process, there is no heat transition. Okay. Now this process 2 to 3, in this process, this 100 kilojoule of heat, is added. That's why this plus sign is there. 100 kilojoule of heat is added at 500 Kelvin. So this is 500 Kelvin. Okay, this is process 2 to 3. Now the process 3 to 4. Once again, this is isentropic expansion process. In isentropic process, there is no heat exchange. Therefore, no heat. Okay, so Q will be 0. Now this process 4 to 5. Once again, this is heat added. This 40 kilojoule of heat is added at 400 Kelvin. Therefore, this sign will be positive, and this addition of 40 kilojoule is at 400 Kelvin. The process 5 to 6, once again this isentropic expansion, there is no heat addition, and the process 6 to 1, this 40 kilojoule of heat is rejected. In process 6 to 1, this QR amount of heat is rejected at 300 Kelvin. This is 300 Kelvin, from where you can find out QR. After calculation, this QR is 90 kilojoule. Okay, therefore it means this 90 kilojoule of heat is rejected at 300 Kelvin. Now we have to find the work output. Okay, so we know that as per FLTD4 cycle, we know that cyclic integral of dq is equal to cyclic integral of dw. This implies w net is equal to q1 to 2. This not net heat addition in all process. q2 to 3, q3 to 4, q4 to 5, plus q5 to 6, plus Q61. Well, in process 1 to 2, this is isentropic compression process, so therefore there is no heat addition. This is 0. Now process 2 to 3, 100 kilojoule of heat is added. This is 100 kilojoule of heat is added. In process 3 to 4, once again this is isentropic expansion process. There is no heat exchange. Process 4 to 5, this 40 kilojoule of heat is added. 40 kilojoule of heat is added. 5 to 6, there is no heat exchange because this isentropic process, and Q6 to 1, since this 90 kilojoule of heat is rejected, therefore this is equal to 50 kilojoule. So in this process, in this cyclic modified reversible Carnot cycle, net work output is 50 kilojoule. So the answer will be 50 kilojoule. Well, we'll meet in next session.